Defined functions. Piecewise defined functions are functions that have pieces. Seems like a no-brainer, right? With piecewise defined functions, and some of you have seen this in Algebra 2. Some of you may not have seen as much of it in Algebra 2, depending on what year you took it. If you had me in the last couple of semesters, you've seen it. But we're going to get a little better at it this time. There are parts. There's a part A, and it's going to be some sort of equation. And then they'll give you a domain for that part, saying, okay, the x values for these are the x values that work for that part. And then they'll give you a part B. And they'll get you, a domain for that. And they'll say, okay, well, maybe, if, domain A might be from negative infinity up to 2. And then domain B might start at 2 and go to 7, something like that. They're going to tell you what x is there. And then part C, they won't always have 3 parts, but a lot of these do. Part C, and then they're going to give you a domain for that. And our job is going to be to find the domain, the range, any intercepts that we have, and then this thing called continuity, which is the easiest part. Continuity is the hardest word, but the easiest part of this particular thing. So what we're going to do is, as we're doing this, with each part, there are things that I call important points. Okay? Important points are related to the domains of each part. Okay, with each domain, there's going to be at least one important point. Some of them are going to have 2 important points or more out of that. But the important points are related directly to what they tell you the domain is. Okay, so when we're looking at these, when I say important points, you need to look to the x values that are given in the domain. That's where those are going to come from. So let's just start with f of x. And let's get some parts. 3x minus or plus 2. And the domain for that is x is less than negative 2. And then 6, negative 2 less than or equal to x less than or equal to 4. And then the third part, let's do negative 2x when x is greater than 4. All right. Now, there's 3 parts, so we're going to do this in 3 parts, 3 sections, okay? With the first part, we want to look at that domain, and we see that it's for all x's that are less than negative 2. So that means everywhere the x is less than negative 2, the graph is going to look like 3x plus 2. So when we look at that, we want to think, okay, what's an important point for that? An important point would be where x is negative 2. So we plug in negative 2 into that particular function and try to find the y value that goes with it. Okay? So if I plug in negative 2 to 3x plus 2, it's going to be negative 6 plus 2, which is negative 4. That's an important point. Okay? So when I go to graph this, I'm going to draw a coordinate plane here. That point, negative 2, negative 4, is important. Is it included? As in, is it a filled-in circle or an open circle? Very good. There's no equal to mark, so it's an open one. So I'm going to negative 2, negative 4, and I'm putting an open circle because there's no equal to mark on that. Now, everything else that's happening with that part is happening where x is less than negative 2. So x is less than negative 2 is going to be to the left of this. Okay? What do we know this graph looks like? 3x plus 2. Is it a parabola? Is it a squig? Mx plus b. So it means it's a what? Linear equation. It makes a straight line, right? And it has a slope of 3. The y-intercept of 2 technically doesn't matter here because if the y-intercept's 2, what's the x value there? 0, and 0 is bigger than -2, and that's not in our domain. So we're looking at the left side of that. So one way to get that, knowing it's linear, we can go from this point that we've made here, the -2, -4, we can count that 3 slope to the left. And I'm going to count it to the left. I would go down 3 over 1. Down 3. I did that twice and got those 2 points there. What's another way to get those 2 points? Exactly. So Brandon said plug in -3 and -4 for x. Plug in some x values that are less than -2. Like -3. If I plug in -3, be -9 plus 2 is -7. And guess what? That's that point right there. Okay, that's that point right there. If I plug in -4 for x, I get -12 plus 2 is -10. And that's that point right there. Okay, so knowing it's linear, you can count the slope down and to the left in this case because it's x is less than -2 going left, or you can plug in x values that are less than that. Okay, so knowing how to do that both ways is going to be important because it's not always going to be a linear piece. We'll come in contact with some that are not. Okay, so we've graphed the first piece. Let's get to part B. The f of x equals 6 when x is -2 to 4. That's what that says. What's the important points there? Okay, less than 4, but more than -2. All right, so if x is -2, what's y? 6. If x is 4, what's y? 6. No matter what, that equation says y equals 6, no matter what x value you got. Now, those are important points. What do we know about the graph of y equals 6? Yeah, it's horizontal line, straight across at 6 on the y-axis. Ours starts at -2, 6 and goes to 4, 6. Are those filled in circles or open circles? Why are they filled in this time? Got the equal to mark. So 1, 2, 3, 4, 5, 6. Horizontal line. Right there. Part B is done. Part C. Green. What's the important x value in part C? 4. It's that 4 that's out here. Okay. So if I plug 4 into -2x, what's my y value? -8. Is that an open circle or a filled in dot? Open. It doesn't have an equal to mark. So I'm going to 4, -8. And then what do we know about that graph? -2x. Slope is -2. And that to count that, which way are we going? To the left or to the right? Yeah, it says greater than 4, so I'm going to have to go to the right. So if I go down 2, right 1, that works. What's the other way that I could get those points? I could plug in x values that are greater than 4 and get points that go with that. If I don't know exactly what the shape looks like, I can always plug in some ordered pairs to get a better idea. Okay, we know that that's a straight line because it's -2x. We know that. We've been working with that for a long time. Okay, now we've graphed all 3 parts. That's the first thing we want to do. Let's look at those important things, Kylie. I plugged in this 4 in for x right there. -2 times 4 is that -8. We just got the y value that goes with that 4 that was in our the given domain part for that. Okay. All right. Now let's get the domain for the entire problem. Well, let's look. You can look at the graph. You can look at the givens here and get it both ways. Okay. This one says x's that are less than -2. So where does that go? From negative infinity all the way up to -2, right? And then this one, does it pick up the -2? As in it uses it? Yeah, it picks it up. And then it goes up to 4, and it's keeping the 4 too. So we're using the 4. And then this one starts at 4 and goes where? All the way to positive infinity, right? So are there any numbers that are left out? No, no x values are left out. So what's our domain? All real numbers. And we'll write it negative infinity to positive infinity. The range. Range can be done without the graph. It's not necessarily very easy to do without the graph. Okay, got to have that graph. Really, it makes the range very easy, or much easier. Maybe not very easy, but much easier. If I look at that graph, remember, how do we find range? Which way do we read it? Top to bottom or bottom to top? Bottom top. Because remember, your range, it's like, domain goes from the smallest values to the biggest one. Range, the smallest values are down here. Biggest ones are at the top. So we're going to read bottom to top. So when we read bottom to top, what's this red one doing? It's going down toward what? Negative infinity. What's this green one doing? Same thing. Where does it stop as we're reading up?
The top line, the 6.
Okay, it stops up there, but does it stop anywhere before then? Stops right there, but this red one kind of takes care of that, right? So it's got some y values that work there. And then here, that's a stopping spot. So we got a gap between here and the blue line. So we got to write into our range. So we go from negative infinity up to what's this point? -2, -4. So our range starts at negative infinity and gets up to -4. Is that -4 included or not? It's an empty circle, so parentheses. And then what's the other part of the range? This was a little tricky, but just 6. What are all the y values in the blue line? Every one of them 6. So just 6. Okay. Range, looking at the graph, is really the best thing. Read it bottom to top. Domain you can get from the inequalities they give you. Range, you almost have to have that graph. Let's look at intercepts. We've talked about intercepts already. What kind of intercepts are we looking for? X and Y. Are there any X intercepts for this one? No. Okay. Are there any Y intercepts? 6. So the intercept would be at 0, 6. Okay. Now, here's the last thing that, maybe it's a new thing. Here. Let me write that where you can read it. Continuity. It's like the word continuous, but ended in an ITY instead. Continuity. Continuity means continuous. If something is continuous, does it ever stop or skip spots or anything like that? No. Okay, so if you're testing continuity of a graph, you got to look at it, and here's the kind of the best way of thinking about it. Can I draw it without picking up my pencil? Can I trace it without picking up my pencil? This one, obviously, you can't, because I've got to pick up my pencil to get up here and draw it, and then pick it up again. So this one would be what we call discontinuous. I can't spell. discontin. There we go. Discontinuous is what this is called. If you can trace the graph without having to pick up your pencil and there are no holes in the graph, that you got to hop over, then that's continuous. So continuity, your answers are going to be continuous or discontinuous, and it's all based on that idea. Can I trace it without picking up my pencil? If I can, it's continuous. If I can't, it's discontinuous. Yeah. All right. So let's look at another one, maybe a little bit more college level. Example B. G of x squared, and x is less than 2. Negative 3x plus 5, and x is greater than or equal to 2. So I want to graph this. What do we know about that first part? It's a quadratic. So what kind of shape should we know it makes? Not a V, but a parabola. So a kind of U-shaped a little bit. Not quite a U, but maybe the cross between a U and a V. Now, what's an important point for that parabola? Okay, so if I plug in 2, I get 2, 4. When we were graphing parabolas back in Algebra 1, and we did it again in Algebra 2, what was also an important point for every quadratic that we graphed? The vertex. Okay, what's the vertex of x squared? Or the minimum or maximum. Remember, vertex was minimum and maximum. 0, 0, right? That's an important point, and I count it because is 0 less than 2 for the x value? Yes. Okay. If the x value of the vertex is not fit in your domain, then the vertex is not an important point for that particular piecewise graph. Okay, because we know the vertex of that is 0, 0. 0 is inside of this, so we count it as an important point. That's going to help us get that shape out of that. Since it's a quadratic, yes, ma'am. It is based on just general knowledge about x squared, the parent graph for the squaring function or the quadratic function, is that the vertex starts at 0, 0 if it's just plain x squared. If we have something like plus 5x or something like that, that changes, and there's some other things that we'll talk about how to fix there, but you won't get too complicated with this particular part. Now, what other point would be a good one to have to get this graph to look really nice? I heard somebody whisper -2. Why do we know -2? If I plug that in, -2 squared is 4. Why do I know that that's an important point or would help draw this graph? It's the other side, and we know that x squared is what kind of function? It's quadratic, but it's also even. And if it's even, what is it symmetric with respect to? The y-axis. So we flip across the y-axis. The flip across the y-axis to 2, 4 is -2, 4. Okay, because it changes the x value. So we can plot those points. And then 2, 4 is going to be an open circle because it's not included. And then I'm going to draw that parabola. So get kind of close there. Not quite a V. It's kind of soft in the bottom there. U shape. And then the second part, we've got -3x plus 5 when x is greater than or equal to 2. So the first point we need to worry about with that would be at 2. What's our y value? -1. Plugging that in, -6 plus 5, -1. So 2, -1. And filled in or open? Filled in. Okay. What do we know about that graph? Slope of -3. It's a line, so we can draw a straight line. We can use those things we know about drawing lines. If the slope is -3, I can go down 3, right 1. I can get that picture going. I could also plug in x values. that are bigger than 2 and get the same thing happening. If you don't have the general knowledge about the functions, it takes a little longer to work it. You got to plug in x values and get points. So the general, the idea of that chart is that you got some general knowledge about some of the functions. You got to know what the shape looks like so that you don't have to sit there and plug in points so much that, that you end up just plugging in points forever. Okay. All right. Let's look at the graphing calculator real quick, and I'll show you a little trick on it that I think can help us in checking these at least. Because you're going to have to draw some, actually draw it, but being able to use the graphing calculator to kind of check and see if you're going the right way. Obviously, my thing was out of whack there, so it zoom 6, and then I'm going to clear out my y equals menu here and get rid of this stuff from whenever I did that. Okay. All right, so the first function is x squared. I'm going to put it in parentheses, x squared, and then close the parentheses. Then I'm going to hit the division symbol, and this is where the inequality comes in. And I think this is, if I remember correctly, this is how I don't ever do it on the calculator. So parentheses x, and then I'm going to hit second math. And that gets me the inequality symbols. And I need a less than, which is number 5. And then 2. And I'm going to graph just that part to make sure I did it right. I think that's right. Yeah. Notice how it just graphed that part. That's kind of neat, handy. So the key to that, on your y equals, you got to put the function, the equation part in parentheses, a division symbol, and then put the inequality part in parentheses. Okay. Now, y2, I'm going to put in the negative 3x plus 5. Negative 3. I didn't put it in parentheses. There we go. Negative, still didn't do it. This is negative 3x plus 5. Close parentheses. Divided by parentheses x. And then to get the inequality symbol, I hit second math. And I want greater than or equal to, which is 4. And then 2. And hit graph. And I should see both of them now. So my graph. Can't really see the open circle. It doesn't put that kind of stuff on there, but you get a view of that. Now, where we run into problems with this is the compound inequalities. You've got to split those apart and to do 2 of them for that, which makes it quite entertaining. And we'll get to one of those. We'll do. Well, heck, we can just look at what was the example A. It had a 3-part. Yeah. Let's look at example A on the calculator. So if we're looking at example A on the calculator, going back up there, looking at that and just getting it to graph it for us. On the y equals menu, I'm just going to clear those out. Y1, I'm going to put 3x plus 2 in parentheses. Divided by x is less than second math negative 2. And then the second one, y equals 6. And then it says that from negative 2 is less than x is less than 4. If you try to put that in there, I don't think it can handle it. We'll try. I don't think it can handle it. We'll try it. Less than or equal to, which is 6 x 4. We'll see. It'll graph the first one. I bet it gives me an error on the second. Nah, it didn't cut it off. So because it couldn't handle that, it just graphed the y equals 6. Okay. If I delete this. Graph. I actually think let's try this second test. I'm gonna try this. May not work. Like I said, I don't do these on the calculator ever. Just because it's just as easy to do by hand. We'll try that. I don't know if it'll work. The logic will work or not. Hey, it did. All right. Yeah, that's how we're gonna do it. All right. So to get it to do that on the second one, let's clear it out and start over. Parentheses 6 divided by parentheses, and then you're going to split that compound inequality into two. So the first one is going to be the left side of it. -2 is less than or equal to x. So -2, second test, less than or equal to x. And then you're going to put the and in there, which is second math. Go over to logic and click and. And then x is less than or equal to 4. So x is second math less than or equal to 4. And then when you graph that, you'll get part 1 or part A, part B, and then we're going to get part C in Y3. -2x. And I didn't put it in parentheses again. I keep forgetting. Divided by, and then we're doing x is greater than 4, so only, that's not too difficult. And there we get that piece there. You can see just a little bit of it. So we can get the graphing calculator to draw them. It helps us decide if we did it right or not. If we can type it in correctly. The typing it in correctly is the difficult part. Not letting you do which part? Oh, you did a minus. You did a minus. That's what it was. The minus sign and the negative sign. It reads them as different things. Mathematically, they're the same, but calculator language, they're not. All right, let's look at another piecewise here. Example C. Let's call this one f of x. And let's do 2 plus x for x is less than 0, and then x cubed for x is greater than 0. We didn't do the domain and range and all that stuff the previous one. Let's go back and do that. Sorry. Won't take long. Domain. Any x values left out? We look at our inequalities, we go from negative infinity up to 2. We go from, is 2 included here? So it picked it up, and then it goes greater than 2. So it's all real numbers again. Won't always be that, just happens to be this time. Range. Reading it from bottom to top, remember? So the green one's on the bottom here, so that's pointing down. So we're starting at where? Negative infinity, and it stops right here. At what y value? Does the blue one pick up the -1 y value? No. So we're stopping at -1. Is -1 included or not? It is, because the dot is what? Filled in. So we put a bracket, union, What's the first y value on the blue one? 0. And then it goes how far? To infinity. The right side stops here at 4, but the left side keeps going to infinity. So whichever one goes furthest. So there's our range. Intercepts. There's only one. 0, 0. And continuity. Discontinuous. Because you had to pick up your pencil. Right. All right. Come down here to see. Only 2 parts on this one. One of those is an interesting one. X cubed. So let's get the first one there. Important point for part A. It's the 0, 0, 2. Okay. That's important. Happens to be the what for that particular graph? The y-intercept, right? For x is 0, it's going to be your y-intercept. All right, so I'm going to go to 0, 2. Is that point included or not? No. So open circle on the 0, 2. Which way are we going, left or right? Left. What's the slope of that line? 1. Down 1, left 1. I could also just plug in some x values that are less than 0, get those y values that go with it. That works. Okay. I know it's a positive 1 slope, so I know if positive slope goes up and to the right, we happen to be going down and to the left for our graph. So we'll down 1, left 1. Out of that. Go. All right. Now, x cubed and x is greater than 0. What's the important point? 0, 0. Because if I plug 0 in for x, 0 cubed is still 0. Okay, so is that point included or not? No. Okay, open circle on 0, 0. What does x cubed do? Do we know? No, x squared is a parabola. X cubed looks like this normally. That's what the normal x cubed graph looks like. This one is only the part from 0 to infinity. So what can I do to get some points that way? Plug in 1 and 2 and maybe 3. 1 plugged in, 1 cubed is 1. 2 cubed, 8. 3 cubed. Okay, that's too far. Okay, I don't have room to fit that. So it gets you just this thing going on. So it kind of looks like half a parabola, but it's half of the x cubed graph. Is what it ends up being. Okay. Let's get the domain of that. Any x values left out? So reading it left to right, negative infinity. There we go. What about, there's no equal to mark on the 0 on either one. So 0's got to be left out. If it's not equal to on either one of them, then 0's left out. We got to skip it. There would be our domain. About a range. Reading it bottom to top, so the red one's pointing down to negative infinity, so we know that's happening. And it goes up to 2. and then the blue one jumps back down. So, all these y values are already taken, and then it keeps going up to positive infinity. Are there any y values left out? No. Well, the y value of 0, it's taken care of by the red one. The blue one, it has a hole there, but the red one had a y value there, so it is used by one of the pieces. So this one would be negative infinity to positive infinity. So you've got to kind of look at it and say, okay, does anybody else use the y value that's left out of this one? If they do, then it's taken care of and it's not skipped. Okay. Intercepts.
But there's the one right there, in the negative.
So what kind of intercept is it?
It's no X.
An x-intercept right here. Yeah, right there. That's the one Kylie's talking about. That's an x-intercept. These two, she's correct saying they're not included because they're open circles, right? So yeah, the graph goes to that point, but it doesn't include that point. So it can't be an intercept if it's not included. So details here are kind of important. So here is our only intercept at -2, 0. Continuity. Discontinuous again. That's kind of a trend here. Doesn't mean that they're all discontinuous. But a whole lot of them are. just so you know. All right. One more. Call this one g of x. Change it up a little bit. 5 minus x for -3 is less than or equal to x is less than 1. And then the square root of x for x is greater than. Is it E? Sorry. D, sorry. My bad. I'm looking at my old notes here and I skipped some of the other stuff at the front that we did on the chart. So my letters are off there. All right, yeah, that's it. Just 2 pieces on this one. All right, what's the first thing we do? All right, I'll sit here and say nothing. Okay, what are they? Okay, 1 was the y value that goes with 1. Try again. Because 1 was the only one anybody said. I'm going on you guys. You got to do this. -3 would also be 1 of the important points. Both of them, because we got a compound inequality there. Okay. So +8. So those two are important points. So we're going to go plot those. -3, +8. 1, 2, 3, 4, 5, 6, 7, 8. That's an included point because it's got an equal to mark. And then I go to 1, 4. Open or filled in? I got 2 different answers. Why? Not equal to, so that's why it's open. Good job. Really open. I'm still trying to be big. There we go. That's better. Now, what do we know about the area between? It's a slope of -1, and it's a straight line, right? So do we really even have to count the slope? No, we can just connect those with a straight line because we know that 5 minus x is a straight line. Okay? If that were like 5 minus x squared, we would probably need to plug in x values that are between -3 and 1 to get the shape that's happening there, get that curve happening. But because we know it's a straight line, we're just going to do that. Okay. Important point for part B. 1 square root of 1 is 1. And so 1, 1. Open or filled in? Open. What does the square root of x look like? Yeah, it kind of looks like the top half of a parabola, or the one side of a parabola kind of goes up like this. How can we get that curve, better than just saying, that? Plug what kind of numbers? Anything bigger than 1. So what kind of numbers are easy to take the square root of that are bigger than 1? 4, 9, 16, those kind of numbers. That's what I'd pick. So if I plug in 4 square root of 4 is 2. So I've got the point 4, 2, 3, 4, 2. And if I plug in 9, 9, 3, 5, 6, 7, 8, 9, 3. I could do 16, 4 if I wanted to. That, just get the idea that it's a curve there. It looks kind of straight, but it's got a little curve to it. Flattened out there a lot. Now, domain. What's our domain? -3. What gets a bracket? The -3 gets a bracket. And then 1. And we're skipping 1 altogether. Nobody uses 1. Is that right? Just want to make sure I'm writing the right thing here. And then what? 1 to infinity. Yeah, that's right. The blue one picks it up from 1 or right after 1 and goes out to infinity there for the domain. Range. We're reading bottom to top. So when we read it bottom to top, who do we come in contact with first? Blue one, all right? What's its lowest y value? Is it included? No, so parenthesis. What does the blue one continue to do? It goes on up to infinity. It takes it a while, but it does continue to rise on up toward infinity. So it's 1 to infinity. And even though the red one stops here at 8, the blue one at some point, when x is 64, it's going to reach 8. Or when x is 81, it's going to be above 8 because it's 9. We can find the exact point there, but nope, not really a need. Intercepts. Try again. 0, 5. Remember, 1, 4 was that open circle there, so that go up 1 from there. So 0, 5. Continuous, discontinuous. Discontinuous. All right. It's 248. 949. Odd would be a great place to start with this section. There's a little bit of stuff there at the beginning about some of the functions from your chart. If you don't know for sure, you got a graphing calculator, graph the function that they're talking about and see what's going on out of that. All right. So a little practice there. Got a work day tomorrow, even though we got about 20 minutes left in class today. Be a work day tomorrow, and then quiz on Wednesday over 3-4.